Hey, good morning everyone and welcome to your channel Learn Data Science with Pranjal. So this is the third video in time series modeling. In the first video I have talked about what are the patterns involved in time series model. In the second video we discussed that what is stationarity and what are the assumptions of stationarity, and basically how does the plot of stationary time series looks like. So in this video, we will discuss how to check the stationarity in our code and what to do if our data is not stationary. Because keep in one thing in mind that before building the model, we need to make sure that our data is stationary. That is the main assumption in the time series modeling. Okay, so let's quickly go through the code and we will discuss how to check if the data is stationary or not, and then what to do if it is not stationary. So there can be multiple ways in which you can check the stationarity, but the best way is you do a plot and observe the plot with your naked eyes. That gives you uh, the best result. Though there are a few statistical tests as well, which will give you the answer in p-values to check if the data is stationary or not. So those statistical tests I will discuss in my some another video. But in today's, let's see how to uh, check the data is stationary or not using our plots. So what I've done is I've done some necessary imports, pandas, numpy plot, and this is what my data is. So over here, if you notice, this is your air passenger data set. It is a very standard data set for any person who is trying to practice on time series. It is easily available on your websites, different websites. So it has 144 records and it has two columns, month and the passengers. So passengers as in how many passengers are traveling from a particular airport, you can say, and the numbers are in thousand. So when I say 112, it means 112,000, and 118 is nothing but 118,000. So there are two columns, one is month and is passenger. So before doing time series, what I'm doing, I'm converting my month into date time format. So if you notice the month column, the data type of month is object type, though we know that month is referring to a time interval, but as of now, it is taken as your object column. So what do? I convert it into date time format. Now, after converting into date time format, if you notice, month is taken as your date time. Okay. Now, what I do is I set my month as an index column. So after line number 117, if you notice that there is only just one column, that is your passenger column, because month column is anyway taken as your index column. Okay. Now, I do a plot on my data frame. And from this plot, if you notice, the data is not stationary, because the stationary data would look something like this. The stationary data would look something like this, where on your y-axis you have your values and on your x-axis you have your time. So coming back to over here. So from this graph, we can see that that my data is in uptrend. So the values are increasing over the period, over the years. And within the year, if you notice, the data is seasonal as well. So the values increase and decrease within the year. And year on year basis, the values are in uptrend. So the series is in uptrend as well. And series is seasonal also. And series is non-stationary. Okay. Now, if the data is non-stationary, so what is the approach or what is the method which we can take to make it stationary? And the method is very simple. That is your differencing. Differencing, as the name suggests, taking the difference. But difference of what? Difference of first term and the second term. So let me run my code from the first this thing. So if I have to take the differencing, so what I'll do is I'll do something like this. 100, I will subtract 112 from 118. I will subtract 118 from 132. I'll subtract 132 from 129. I'll subtract 129 from 121. I'll subtract 121 from 135. That is what your differencing is. So differencing will try to make your data stationary. So now this is how my original data looks like. I do a plot, and then if I take a differencing, so can you notice the 6 comes over here? And why does the 6 comes over why does the 6 comes over here? 6 comes over here because if I subtract 112 from 118, it is 6. 130, if I subtract 118 from 132, then you will notice you will get 14. And if you subtract 132 from 129, then you will get minus 3. So that is what your differencing is. So after differencing, your data might have got stationary, or it may not be stationary. So what you need to do is you do a plot. So I do a plot once more. So over here, if you notice, the data has become little better. Data has become little better. So for stationary, the mean and the variance should be fixed. So over here, you can notice the mean has kind of become fixed. So if we move on this line, which is parallel to 0 or parallel to x-axis, you can notice the mean has become fixed. But the variance is still not same. Variance in the year 1950 and the variance in year 1956 and the variance in year 1960 are different. So the variance keeps on changing. The variance is increasing. Okay, so if you want, you can do one more level of differencing. So over here, I have done two levels of differencing. If what you can do is you can do one level of differencing. And if you want to do second level of differencing, you can again add DIFF. If you want to do three level of differencing, you can again add this. But it is not suggested that you go beyond two level or three level of differencing. But having said that, there is no stopping point. Obviously, you can go beyond two or three, but normally it's not advisable to go beyond two and three. So even after a three level of differencing, data has improved, but still doesn't seems to be that stationary. So we can do something different. So what I've done is I have taken approach of converting my data into log. So we already know that log gives the smoothing effect. The large numbers get converted into a smaller range. So for example, if you take a log of 100, the log of 100 becomes 2, the log of 1000 becomes 3. So the large numbers will come in a very small range. So what I do is first of all, let me take a log. So if I take a log, these are my log numbers. Then what I'll do is if I plot plt dot plot this, if I plot the log values, then you notice that variance in this plot, variance has been taken care of. So when you move along this line, you will notice the variance probably will not change, but the mean is changing. Now what if I take a differencing? Now, if we see this data, this looks to be perfectly stationary. Okay, so many a times, if you notice, if you are not able to convert your data into stationary, if you are not able to achieve the stationarity just by differencing, try using log, and and it gives you very good results, because by taking the log, you have already taken care of your variance part, because the data comes in a very small range, and if a data is in very small range, variance cannot be very high. And then if you do the differencing, you have achieved your stationarity. Okay, so that's it in this video. Thank you Brian for watching the video. In my next video, I'll talk about what are the different models in my time series.